Okay, here we go. Okay, so what I'm going to do is the solve the Big Bang Theory. So what I'm going to do is solve the Big Bang Theory. Let's see. This is a theory describes the universe expanding, initial state of high density and temperature, cosmological models of the Big Bang, explain the evolution of observable universe in the earliest known periods through its consequent large-scale form. These models offer a comprehensive explanation for a broad range, including the abundance of light elements, cosmic microwave background radiation, large-scale structure, the overall uniformity of the universe, and flatness problem. Cosmic inflation, very rapid expansion of space during the earliest moments. However, lacks a widely accepted theory of quantum gravity, the earliest conditions of the Big Bang. Crucially, these models are comparable to the Hubble limiter law, the observation that the farther away a galaxy is, faster it is moving away from Earth. The cosmic expansion, the Big Bang singularities, continuing on and on and on and on. Theory of relativity, etc., and so forth. Okay, so let's go to the beginning. Galaxies, okay. This is a picture of the Milky Way galaxy. Yeah, so this is the Milky Way, right? So I wish I knew what the width of the yeah, it's kind of wide, isn't it? Anyway, that's the so the Milky Way is a mass of this is important right here. So it is 3,500 light years. Oh, I see. It is 87,400 light years across from one side to the next. For 87,000 light years. Apparently, I'm going to have to get a calculator open. There we go. There's our calculator. Can you see that? Oh no, wait, you can't even see that. Hang on. Let me minimize this so you can actually see it. Can you see it? No, apparently not. Hang on. Minimize that too. There we go. Oh, wonderful. I can't I can't show you can't show you Wikipedia for some reason. Okay. Nope, that's not it. Game capture's off. Oh, I see. Oh, it doesn't see anything down below. What about that? Does that work? And then no, that doesn't work either. Okay. Alright, hang on. We're going to figure it out. So for the screen capture, it's... Oh, okay. It has to be whatever's on the screen. This one. Okay, there we go. Okay, you're not going to see my calculator, which is on the screen, but that's okay. Alright, let me minimize the calculator as well. So, the over here, the mass of the mass, it's the intrinsic property of a body. Okay, so it is 1.5 times 10 to the 12th masses. Solar mass is, I believe it's a weight of our sun. Yeah, so one mass is the mass of our sun, which is 2 times 10 to the 30th in kilograms. Okay, that's fine, just as long as it's 1.15 masses. Okay, so if you look at our Milky Way, it is a mass of 1.15 times 10 to the 12th masses. So it's 10, let's see, 1, 12, 3, 3, 3, 3, 12 trillion suns, 10 to the 12th, so 1.15 times 10 to the 12th, so that's like, let's see, 100,000 million billion, yeah, 1.5 trillion masses of the sun, okay, so 1.5 trillion masses of our sun is what the mass of the Milky Way is. So, okay. So keep that in mind, right? Mass 1.15 times 10 to the 12th. 1.15 trillion masses of our sun is what the mass of the Milky Way is. Our entire solar system weighs 1.15 million suns. So if you have 1.1 million of our suns all together, that's a pretty heavy mass. So let's take, I have to compare our Milky Way with another galaxy of some kind because I want to compare weights, right? The weight of our galaxy, the Milky Way galaxy, to another galaxy somewhere which is also similar. And it doesn't even have to be similar to our Milky Way galaxy. It has to be similar to any other galaxy within the universe in which we live. The Milky Way is not a universe, it is a galaxy. The universe is all of the galaxies and all life and matter that we can see or know of, right? Which includes all the galaxies out there. So now what we have to do is we have to find find another galaxy to compare it to, right? 1 trillion, 1.15 trillion of our suns is what the volume is, okay? So let us find, and we also have to remember that the width of our Milky Way is what, 25,000 light years across, 25 to 26. No, that's a constellation. Oh, that's our galactic center in Sagittarius. Yeah, so the size of our Milky Way is 87,000 light years across. And that's only an error of 3,600 light years. So 87,000 light years across and 1.15 trillion masses of our sun. Okay, so now let's find another galaxy. Okay? And we're solving for the Big Bang Theory. A galaxy, let's find some other ones. The oldest and most distant galaxy observed, which is this one, GN-Z11. So this is the farthest one away. It is a redshift, which I don't care about. It's at 32 billion light years away. It has a mass of 1 times 10 to the 9. So it's actually rather small. So this one is 4,000 light years across. 4,000 light years as compared to ours, which is 87,000 light years. So this one's only 4,000 light years across, and it is at 1 times 10 to the 9th in mass of our sun. So that would be, let's see, 369, 100,000 million. So it's only 1 billion of our suns rather than 1 trillion. So it's 1,000 times smaller than our galaxy. So the galaxy is there, and it could be as small as 1 billion of our suns in mass. The width, 4,000 light years across. Okay. So it's relatively small. To me, that sounds like a really small one. It's young, 4,000 light years across. Yeah, so this is just a redshift galaxy, but it doesn't really. It's among the farthest known. Let's see. It was seen by the James having us redshifts, which I don't care about. Identified by a team. So the Hubble contains farthest galaxy to date. So what this is saying is the Big Bang included all the galaxies as well. And I'm saying this isn't true. I'm going to say that this Big Bang is supposed to involve all the galaxies. I don't believe that. I absolutely do not believe that. That this even happened. Because then it shows cosmic dark ages, first stars, farthest galaxy, and then previous record holder, and then farthest galaxies. I don't believe this because now it says modern. So I don't believe this at all. I really don't. And here's why. Here's why I don't believe this. I think that the Big Bang, did not happen to all universes. I believe that the Big Bang did not happen to all galaxies. A galaxy is birthed and dies and births on its own. Each galaxy is birthed and dies on its own. A galaxy, there's so many, the distance is so far in between of that, all of this cannot be responsible for the Big Bang, growing from the Big Bang at 13.8 billion years ago. The reason why I say that is because it's too far in between these galaxies. We're talking thousands of light years apart. There's no way that these galaxies all came from this point. A galaxy is like an accumulation of stuff that exists out here on its own. It's too far. You can't go from here to here. It's just the matter cannot go from there to there from something, even if this was something. So the matter is out here, and in these galaxies, it is born and then it dies. It contracts. There's something going on here with galaxies that they're just too far apart. Okay, they're way too far apart. There's no way. Like this one here, this one's at a distance of, it's at 32 billion light years away. So you're telling me that that during the Big Bang, this galaxy was still here, 32 billion light years away, but then you have other galaxies which aren't near as old. So how can the older galaxies be from the same point, be from the same place? And that's what they're saying with the Big Bang. In the Big Bang Theory, they're saying that all the things and all the galaxies began at one point. And that's totally false. It can't happen due to the dynamics of gravity and the millions of what is it, the thousands of light years? Um, no, really, in the billions of light years. That is like, that is 13.4 billion light years away. So, because it's so many billions of light years away, and the age of this constellation, or this galaxy is what? The age of this galaxy, I'm looking for it here. It doesn't have an age, okay? It does have a mass of 1 billion of our suns, but it has no age, okay? Light years across, the size, 4,000 light years. Okay, so it's 4,000 light years across. But it's 13.4 present proper distance light travel distance. So anyway, it's billions of light years away, okay? So if the Big Bang Theory actually took place, then those numbers, the age of all of the galaxies would be the same, and they would all be at the same distance. So that's the location of them is too far apart. So I believe that the galaxies of mass have always been there, always. And let's look at the birth of a galaxy. Galaxy birth. So a barrel spiral galaxy. This is a barrel spiral galaxy. Oh, it's a barred. So central barred, composed of stars, interstellar gas, spiral arms. They're out here. As it rotates, it leaves an arm. So these are left out here. And why are they left out here? I believe it's because the star, there's a mass in the middle. And in this middle, it's spewing matter out, which recollects over time. So this one is like a middle-aged galaxy. I'm not saying that it all came from the same. I'm not saying that it came from some other place before, which I'm saying is wrong, like the Big Bang Theory suggests. I'm saying that this galaxy is spewing matter out from the center, and it forms these arms. Then when it's done spewing matter out, it then turns around and everything reverses and comes back to the middle again because gravity takes over. So all this matter is being pushed away out of the center like an expanding air, expanding gas, which push everything out from the center. Because in the middle, there is this ginormous amount of mass, and so which would be in the birthing of a galaxy, and the galaxy is birthed, and whatever's in the middle, whatever mass. If you take all the electrons, if you strip all the electrons out of an atom, what you're left with is this nucleus. But all the electrons, they're all scattered out and about. So if you get enough mass and put them together, all of the neutrons and protons are compressed together. And the electrons don't care, but they still rotate. They're still stuck to the atom. If you take enough atoms, the electrons are still out here orbiting. So if you keep packing atoms together, the electrons are still out here orbiting about. So then you have enough mass that the protons and neutrons are all compressed together, and the nucleus keeps growing. And it keeps growing, and then pretty soon everything keeps adding to it, and then you have a black hole. So this is like the dying of a galaxy when you have a black hole. Okay. So in a black hole, it's a region of space-time gravity is so strong that nothing, including light or other electronic waves, has enough energy to escape it. So it draws everything into it, right? Everything, all things, all gases, electrons, masses of everything. So nothing can escape it. It is the dying of a galaxy because everything is being consumed. It's eating everything within the galaxy. It's reversed. Everything in the expansion of the universe is stops, the expansion stops, and then everything is returning back to the middle of the galaxy. And it continues to do that for eons, which means for millions of trillions of years. The expansion and contraction of a single galaxy is what takes place. And so it contracts into a black hole until it cannot contract anymore. So the presence can be, and we'll find that here. Let's see if we can find it. So black holes are stellar mass forms when massive stars collapse at the end of their life cycle. So stars have a life cycle. And then supermassive black holes with solar masses M may form by absorbing other stars and merging with other black holes. And so then it's a supermassive thing, and then there is a consensus that supermassive black holes exist in the center of most galaxies. So this black hole is in the center of a galaxy, and so it is slowly eating away. So this is basically the galaxy dying. It's being swallowed up, and it draws everything into it within the entire galaxy. Yes, it takes thousands of light years, millions of light years, in order to accomplish this. But it is the dying of a galaxy. And so the galaxy is being consumed. So, and let's see, what does it say about a black hole? Disk friction forming. Okay, from a disk heated by friction forming a quasar. So any matter that falls into a black hole can form an external accretion disk heated by friction forming quasars. Some of the brightest objects in the universe, stars passing too close, supermassive black hole, are shredded into streamers that shine very brightly before being swallowed. And other stars are orbiting a black hole. The orbit can be used to determine the black hole's mass and location. Such can be to exclude possible alternatives such as neutron stars. In this way, have identified numerous stellar black hole candidates and binary systems established radius sources Sagittarius A at the core of the Milky Way galaxy. Contains a supermassive black hole of about 4.3 million solar masses. So it's so big, but it continues to swallow up the entire universe eventually. Okay? Because the universe stops expanding and then it goes to contracting. So what does it make? So the black hole can form an external accretionary disk forming quasars, right? So a quasar is a galactic nucleus. It is the center of a galaxy. And let's see, tens of billions of solar masses. So this is in line with the weight of our galaxy, right? Because we're talking tens of billions of solar masses, right? So whenever if we go back to the Milky Way galaxy and we look at the mass, we have 1.5, and I think this was trillion masses, but that's irrelevant. Whenever you go back to the galaxy or a quasar, back to quasar, you have the where did it go? Yeah, you have, oh, I don't see it. It changed on me. Yeah, so there's almost a million. There's one that's 600 million record detected. So yeah, 600 million solar masses was emitted when the universe was only 690 million years old. In 2020 was detected 700 million years ago after the Big Bang, and an estimated 1.5 billion times the mass of the sun. In early, this one here, 1.6 billion solar mass black hole was reported. So there's a couple of these. These are what turn into new. The most distant quasar. It was identified as the most redshifted quasar, the oldest known supermassive black hole. So a quasar is a black hole. It is also 1.6 trillion. Oh, 3, 6, 9. Oh, okay. This one's only 1.6 billion solar masses. So 1.6 billion times the size of our sun. This one, again, it is a supermassive black hole. And so something happens. And I know that it's spewing the protons out from a beam. Or is it? Let's see. They also spew electrons out because they say, oh, we're getting signals from them. But the actual mass of it is what is there. And so if you have the mass of one of these surveys that demonstrated the quasar was more common in the distant past, was approximately 10 billion years old. Naming, I don't care about naming. Observing, yeah, power density. Oh yeah, this implies an extremely take place over these objects. Unknown, rapidly changing to X-ray range. So some of the change in luminosity to rapidly range, X-ray range. So they're spewing out electrons while their mass is growing. So objects emit large amounts of radiation. That's what I was looking for. So they spew out large amounts of radiation. Located optically, but no source can be located optically. We're in similar point like it is a star. Chemical elements which are composed extremely strange and defined. and defies explanation. Yeah, part of this is because of the power that they emit. They emit electrons out of it. Meanwhile, the light is continuing to be accumulated, or protons. So they continue to consume protons. So there becomes a point where this universe cannot consume anymore. The electrons are still there, wrapped around it. The excess gets spewed out, but all the electrons that are collected up into a black hole are still there orbiting it. In fact, that's what sucks in everything. The electrons end up being so dense that they reach out and grab everything because the protons are attracted to them. So that means everything gets bent and dragged into it. So there becomes a point where a black hole cannot contain anymore, or something happens where this black hole reverses and starts to give itself up, and things come from it. And I'm not sure if it's when oh yeah, that's when it has consumed everything. So for most of the physics of most everything I know of, whenever there's no change in anything, it cools off. So while a black hole is accumulating stuff, it is actually growing, and there's heat being taking place because these things are coming into it. That means it's collecting up energy, growing, staying hot, so that it can continue to be what it is. And it just continues to pull stuff in, and every time it pulls something else in, it gets hotter and it has more energy. So it draws on whatever it's consuming for energy. So the black hole continues to consume stuff. When it can't consume anymore, that means that there's no heat being generated. The black hole then goes a little bit cooler, and then all the energy that it was pulling in stuff is no longer there. It continues to cool more and more. It's not drawing anything in. It is drawing in everything that can be drawn in. Even one star is enough that it can keep generating heat because there's still something there. So at that point, it has reached out, grabbed, and accumulated everything within its grasp. You think even Pluto, out there at the farthest reaches of our solar system, is being held by the gravity of our sun, which, if you look at Pluto, or even Neptune, let me pull up Neptune, because Neptune is, if I can spell it right, Neptunian. So Neptune is way the heck out there. It is, the planet orbits the sun every 164 US or Earth years. So at a distance of 30 astronomical units. So, which I believe 30 astronomical units is how many light years? 1 AU. Oh, it's actually, let's see, Earth to Sun, approximately 150 million kilometers, or 8.3 light minutes. Actual distance from Earth to Sun varies. Oh, yeah, the distance from the Earth to the Sun is what they're calling an astronomical unit. So there are 30, so Neptune is 30 times the distance out there. It's 30 times the distance. So it's from the sun to us, it's 30 times that distance all the way out to Neptune. So you see how small the sun is? It's like that big, and then that's one, right? Neptune is 30 of those all the way out there. So light takes 30 times 8, 240 minutes to reach Neptune. That's how long light from our sun has to travel to get all the way to Neptune. 340 minutes. So it's got like in several hours in order. So it's way out there. The gravity is still there. So back to a black hole. So back to a black hole. So the black hole, the reaches of a black hole, I believe, extend a long ways. I believe that a black hole and the energy of a black hole can reach out and grasp anything out there the size of a galaxy. That's how much energy a black hole is. Yeah, it takes millions of years. It may even take billions of Earth years for that to take place. Light years. It takes billions of light years for a galaxy to be consumed back to a black hole. And the black hole reaches out with gravity and slowly pulls it all back inward. It grows, and the electrons are grown out there all the way to the reaches of the galaxy as it pulls it all back in. And then everything starts that trip back into the black hole. It has then consumed everything. When it's totally consumed everything within the galaxy, and yes, it takes millions of millions of light years in order to accomplish this. But it slowly reaches out there. It pulls it all back in. When it's pulled everything back in, there's no heat being generated because there's nothing for it to consume. There's nothing generating heat. There's no change in the mass. So therefore it goes cold. When it goes cold, it has now lost its energy. And now something miraculous happens. This black hole then goes cold, and now energy is released from it. So in the releasing of the energy from the black hole after it's gone cold, I want to say it is one of these, a pulsar. It's a neutron star, magnetic poles. Nope, I'm still learning. So a pulsar is not it. A pulsar. What is a pulsar? Signals from pulsars. It's an astronomical in nature, not observed before. When observations, instrumental, little green man. What is it? Let me look up here on the top. A pulsar is a highly magnetized rotating neutron star that emits beams of electromagnetic radiation out of its magnetic poles. Radiation can be observed only when a beam of emission is pointing towards Earth. And pulse appearance and emission, so energy. Neutron stars are very dense and have very short, regular rotational periods. Precise interval milliseconds. The source of ultra-high energy cosmic rays. Binary neutron star. Let's take a look at one of these. So this is a pulsar, PSRB. It has a mass of 1.4 MO, so that isn't quite the mass of a galaxy. Okay. So that's not it. Pulsar, dead end. That's not it. So let's go back to the black hole theory. So let's see. Black holes reach a space-time or gravity, including nothing, not even light, can escape it. Okay, so that means it consumes an entire galaxy, basically. Black holes of stellar mass form when massive stars collapse at the end of their life cycle. So yes, that's what happens in our galaxy. That's supermassive black holes in most galaxies, and that's what happened. They collapse and continue to collapse. So The idea of a body so big that not even light, briefly described, Finder John Mitchell, a letter. Mitchell concluded that one would form when a star's diameter exceeds the sun's by a factor of 500 and the surface escape velocity exceeds the usual speed of light. So he correctly noted that such a supermassive black hole by non-radiating bodies, whereby visible bodies initially giant visible dark stars, wave-like nature. Okay, that's the notion, free falling back into the star's surface. So that's that. Relatively, I don't know what that is. Anyway, that's what I'm saying. I'm saying that the supermassive black hole exists at the center of a galaxy for a reason. That is the end of the galaxy. The galaxy is ending. It expanded. A couple of stars ended up collapsing, and now it's going to spend the next billion light years contracting. So I got the contraction and the death of the galaxy is a black hole forming in the middle, and then it slowly collapses the entire galaxy upon itself. The birth of the galaxy is a whole other story. That's what I'm not sure about. I do believe that a black hole has the ability to consume the entire galaxy. I do not believe that all the galaxies came from the same place. I really don't. I think that galaxies end up forming and contracting on their own, individually, with no other interaction. There's a galaxy has always been its own galaxy, collapsing and birthing, collapsing and birthing, collapsing and birthing. Galaxies do not mix. There is no one galaxy and another galaxy combined. They maybe if they're close enough together and then they combine, but after they combine, they're now just one galaxy that forever and all of infinite time would collapse and then grow upon itself continually through the infinite time that it exists, and that there's never has been any interaction between galaxies ever in the infinite time of the universe, simply because the distance between them. So take a look at a galaxy, right? Let's go back to galaxies and look at them. If we study galaxies, we'll see why that is. See the distance between them, and then understand why that would be true. Why that galaxies were never together in the beginning. Okay. So usually this mass here, this huge mass of a galaxy it's all together. It's not separate. It is again thousands of light years across, but it did not come from someplace else. It has collapsed and borne upon itself over and over again. Right, so this one is, it's 62 million light years. So it's a large unit of length. It's to 5.88 trillion miles, which is a long way. It's 5.88 trillion miles. That is a very, very big. So here's a galaxy. This one's a dwarf. It's a catalog of 12,000 galaxies visible from the northern hemisphere. It was published in 1973. So this catalog of galaxies, yeah, they're out there. It's a ring galaxy. It formed, it collapses. One of these was in a collision. Because there was a galaxy of empty space, because most of a galaxy consists of empty space, the collision rarely results in any actual collisions between stars because they're so big. Uh, the disruptions caused by such could cause a wave of star formation to move through the larger galaxy. Other astronomers think that rings are formed around some galaxies when external accretion takes place. Star formation would then take place in the accreted material because of shock and compressions of accreted material. Okay, so that's a ring galaxy. That's it's a galaxy, but look at the center. It's a center energy in the middle, and this one looks like something is consuming it. So either something's being consumed in here, or or this was part of the expansion and when it was created. So the center of this particular galaxy exploded or went to spewing its contents outward, and then it stopped, it finished. And so the mass stopped, and so therefore it's still going outward. That is, if this is expanding. If this is expanding, then the mass emptied itself of no more mass to be able to expand, and depleted whatever coming from the center, and therefore there's this gap because the mass that was expanding was not being supplied from the center anymore. And so now it looks like a donut. The other side of that is this could be a black hole in the middle, and it's slowly eating away, consuming the stuff. So as it continues to eat away at the inner part of this galaxy, it's being pulled back into the middle. It's quite possible. So that could be why there's a ring there. That's that. A ring. A phenomenon, rotational velocity increases the point of spiral spin out under typical gravitational density waves. Would favor the creation of an arm. When the bar is unstable, waves are instead migrated out into a ring structure by the pressure, force, and gravitational influence of the baryonic and dark matter furiously orbiting about the bar. This migration forces stars, gas, and dust found within the former arms into a torus-like region, forming a ring and often igniting star formation. So galaxies with this have been found where the bar dominates, essentially carves out the ring as it rotates. Oppositely, ring galaxies have been found where the bar has collapsed or disintegrated into a highly flattened bulge. Despite this, the bar's ring spiral arms have the ability to fall apart and reform over the span of hundreds of million years, particularly in dense intergalactic environments. Such a galaxy group and clusters where gravitational influences are more likely to play a role in the morphological and physical evolution of a galaxy without the influence of collisions and mergers. So this one kind of touches on what I'm talking about. Okay, there's a collapse and expansion there. There is the galaxy has the ability to fall apart and reform over the span of hundreds of millions of years. So it can actually collapse and then collapse completely into the center, and then it becomes one big large mass in the center of the galaxy, and then it spreads itself out over again. So the collision can either launch the bulge or core let's see, galactic collisions. This may be something touching on it. Um, Outward arm of the gravity of smaller galaxy, if dropping a rock into a pond, can either launch the bulge or core away from the main disk, creating an almost empty ring appearance, also causing awful oval-shaped ring. Inside swipe and head-on collision rings formed through the collision process. So this one also talks about, of course, it takes billions of years to complete. It's a short time frame, but it can take over billions of years to complete. So the rings formed, and it lasted a few 100 million years, over billions of years, before disintegrating, reforming into spiral arms to further the surface for gravitational influence. So yes, it would all fall together, and then it would spiral out again into a different type of galaxy. And this is a very dynamic environment here because the galaxy is always contracting and reforming. Just throughout to be forming protogalaxies. I have no idea what that is. A protogalaxy, which could be called a primeval galaxy, is a cloud of gas. It is believed that the rate of star formation during this galactic evolution will determine whether it is spiral or elliptical galaxy, a slower star formation. So yeah, that means it's just gases, right? Okay, is it going to make a star? Is it going to make planets? What is it doing? So it's just this gigantic gas out in the, but that means can you think of 1 trillion, the mass of 1 trillion suns and gas just sitting there? I don't. That's why I'm saying that. It's a mass that's so huge that it just breaks apart because it's so weak. And now it's going outward, but it also would spin. To me, I think it would spin. Let's see. So that one there's a lot of talk about how they're collapsing. They collide, they interact, they then expand. So this is from a ring galaxy. Let's see. If we go back to the Cardwheel Galaxy. So there's this one, right? It's a cartwheel. But look at this in the middle. So 500 million light years away is a constellation of Sculptor. This image is a composite image, James Webb. So look at the middle. Can you think about what's going on here? So this is either expanding or contracting. You can't tell. Okay. I do see that there is a definite ring out here, so apparently it had to start somewhere. That means that there was some kind of expansion that took place at the same time. At one time, there was an expansion of matter. Okay, it had to like kaboof and then start expanding in this one galaxy. Okay. This one, it's 500 million light years away. It obviously got enough mass in order to start expanding, and it lost its core. The grip in the core was lost, and so therefore it had to expand. But I don't know what the size is. I don't know what the mass is. If you look at the mass of a galaxy of 1 trillion suns, then yeah, this one here, it says it has a diameter of 144,000 light years. So to me, it sounds small. It doesn't have a mass. It doesn't say what its weight is, but I'm guessing it's pretty heavy. But really small if it's only 144,000 light years across. But we can't tell. And no, it doesn't know what the mass is. Oh, it does here. So it has a mass of 2.9 to 4.8 solar masses. And then its outer ring has a circular velocity of 217 kilometers per second. Oh, it has a diameter of 144,000 light years. It's 500 million light years away. It has a diameter of 44.23 kiloparsec. So its outer ring has a circular velocity, but is it expanding or contracting? I don't know. The span slightly smaller than the Andromeda. But there's something going on here. If this is the actual picture of it, you can see something's going on here. Because if you look at the middle of it, what does it look like? It looks like there's this huge mass. It doesn't have to be a black hole. I'm not saying that the center of a galaxy is a black hole. What I'm saying is when there's a collection of enough mass, it is then collected back into the center. And then when there is the collection of the matter in the middle, it then starts expanding. How that releases, how it's released from the center of the galaxy is what's in question, right? That part of, okay, it's collapsed, and then there's this disappearing act right there. And then, okay, it's expanding, but what happened before it started expanding? So somewhere between the universe contracting and the universe expanding, there's this missing part. Now, to me, it seems like there's a black hole at play here in the middle of this galaxy. But there's got to be something else there. What triggers it to expand again, I don't know. But what is it truly capable of collapsing? That is another good question. I believe that it is. I think that a black hole and gravity has enough energy to collapse the black hole. I think that the initial release is enough to send the galaxy on its way in order to forming. But then on that contraction, when does that take place? It takes something with enough mass in the middle, which is much greater than what's out there, in order to pull it back in. And that's where the gravity of that's where the universe starts dying, where the collapsing takes place. And that's the missing part. So I think that the known part is it expands. They expand. Did they all expand at the same time in the Big Bang? No, they did not. I still don't believe this. This doesn't answer how did the masses of all the galaxies out there form? Well, they're already there. They're already there in a galaxy. The galaxy is doing this for like I said, for eons of time. So I think I would need to study more on the birth of a galaxy. So let me look that up, see if that's in here. Birth of galaxy. I have no idea what I'm going to find on that one. So the birth of a galaxy, and I'm trying to get this on Wikipedia. This one here is the closest, the Andromeda. Closest major galaxy to the Milky Way, where the solar system was originally named, whatever, cataloged, whatever, has a diameter of 152,000 light years. It has a mass of 1.5 trillion star masses. The Milky Way and Andromeda are expected to collide in around 4.5 to 5 billion years, right? So we kind of so if these two galaxies were going to be colliding in 4 or 5 billion years, that means that the Big Bang is not true. Because if the Big Bang Theory was true, all the galaxies would be moving away from each other. the expansion of space would have them all leaving from the same point if it was the Big Bang. So you would have them going kaboosh, and now they're all leaving from the same point, and they would all be going away from each other because everything would be going wider. Everything would be going outward at an angle. Even if it was from the middle and they were all going from the center point outward. That's why I'm saying the Big Bang never took place for all the galaxies. It never took place. A Big Bang for one galaxy? Yes. All the galaxies? No, it didn't happen. Okay, that's what I'm saying. The universe is supposed to include all the galaxies, but you can't do that because there's an infinite number of galaxies out there in an infinite space out there. It has no end. It continues onward. It is infinite. There is an infinite amount of space out there. And the galaxies, if the Big Bang Theory was true, the galaxies would be separating from each other because that's saying that it all originated from the same point. And it didn't happen like that because if these are colliding in 4.5 million years, that means that they're coming together. Oh, somebody threw a curveball, and now they're like, oh, we came from the same point, but now we're doing a curveball and we're going to collide. The galaxy is curving into another one. No, I don't think so. So, the mere fact that the galaxies move like this, it can actually move around and collide. Something had to put them into motion. So, one of the things that I believe is that when the contraction or the dying of the galaxy, you can pick either one. If the two are going to collide, if you can use either one. When the Andromeda Galaxy was concentrated into its central mass of not being a galaxy, but instead a highly concentrated form of a galaxy into this one point, before it released, it put itself into motion into one direction or another. And somehow it ended up putting itself in motion when it released its energy in its formation, after its death and its formation again. It ended up launching itself into a direction. Somehow the center point of energy propelled the galaxy in motion across our path of the Milky Way. So the Milky Way and the Andromeda are now on a collision course or even in the Milky Way. It could have been the Milky Way. So when the Milky Way was a single mass, a single mass, that whenever it was born, the Milky Way propelled itself into the path of the Andromeda Galaxy. And so they're colliding. If it was a Big Bang, that wouldn't be happening unless one of them is through a curveball or something of that nature. So if it was the Big Bang as well, I don't believe that you would have the same mass of a galaxy created. It would be this blob of mass that would be going through space, but by that time it would have formed itself into a galaxy of some sort, still going in another direction, or outward, separating away from each other. And since they're all expanding at the same rate, there is no way that one of them could have accelerated itself into another galaxy, because they would all be accelerating from the same point if it was the Big Bang. So again, that tells me that no, it's not the Big Bang. they did not accelerate from the same point. Okay, I still think that galaxies are concentrated. They die. They fall back to the center, and then this mass, which I don't know about, I'm still thinking it's a supermassive black hole, is the end of a galaxy because the supermassive black hole. If we take a look at that, let's take another look at black holes. Black hole, and then we look at a supermassive black hole. Supermassive black holes are... Supermassive black hole is the largest type of black hole, its mass being order of hundreds of thousands or millions of billions of times the mass of the sun, or even a trillion. So hundreds of billions of the mass of the sun. They are class of astronomical objects undergone gravitational collapse, and so the entire galaxy has gravitational collapse back to a single point. And then at that point, and this also, evidence indicates almost every large galaxy has a supermassive black hole at its center. This is based on that right there, okay? There's this large energy, and that's why I don't believe that the Big Bang took place either. It's because what are these? I mean, they're just corresponding to the radio source, supermassive black holes, active galactic nuclei. So, again, do you think that's convincing enough? Is that the Big Bang never happened? Have I explained it? Have I used Wikipedia to explain with the understanding of black holes and galaxies that the Big Bang never happened? And with my understanding of galaxies and whatnot, I really don't believe the Big Bang happened for all those reasons. So here's some astronomers refer to black holes as greater than 5 billion masses, but not broadly termed, include black holes. So here's one. It's a this one calls it is a broad absorption of red lar quasar located coming beneath 18.2 billion light years from Earth. It possesses one of the most massive black holes ever found. So it's 40 billion masses. So 40 billion suns. But that's not quite the size of a universe, which would be on the order of 1 trillion 1 trillion suns. So, what is this? So this one says supermassive. So as a quasar, ton 618 is believed to be the active galactic nucleus at the center of a galaxy, the engine of which is a supermassive black hole feeding on intensely hot gases and matter and accretion disk. The light orienting quasar is approximately 10.8 billion light years old. Due to the brilliance of the quasar, outshone, not visible, etc., and so forth. Brilliant, making it the brightest object in the known universe. So, 140 trillion, so yeah, that's a star. It's a quasar. Like other ones, spectrum containing emission lines from cooler gas. The size of the broad line. I'm still looking for anything that would give some kind of evidence that here's some more information down here. So 10 billion. The large Magellanic Cloud combined, which is 10 billion solar masses and 15,300 times more massive than Sagittarius A, the Milky Way central black hole. With such high mass, ton 618, may fall into a proposed new classification of ultramassive black hole. A black hole of this mass has a Schwarzschild radius of 1,300 AUs, or about, which is more than 40 times the distance from Neptune to the Sun, and it's a highly, highly concentrated mass. So in a supermassive black hole, mass being hundreds of thousands or millions to billions times the mass of the sun, and that's what I'm talking about. That's the mass of a galaxy. Okay, that's what the mass of a galaxy is. So every sun, there's a planet like 1 trillion suns, 100 billion suns. That's a galaxy. Whenever you put it all together and you pull it all apart, you now have 100 billion suns rotating around each other and all the star stuff in between it. So that. Supermassive black hole, the active galactic nuclei, which is it's a compact region in the center of a galaxy that is a much higher than normal luminosity over at least some portion of the electromagnetic spectrum, with characteristics indicating that the luminosity is not produced by stars, such excess non-stellar emissions. Okay, yeah, that didn't help me understand anything. But they're classified as a mass above 100,000 solar masses, or the volume of a universe. Not a universe, a galaxy. Down here at the bottom, some astronomers refer to black holes of greater than 5 billion masses. An ultramassive black hole are not broadly used. So that was done. Let's look at this one. NGC 6166 is a supermassive type CD galaxy with several smaller galaxies within its envelope. Suspected to have formed a number of galaxy collisions. Again, we're talking about galaxies bumping into each other. If the Big Bang took place, it would not be colliding. They would be going out away from the single point. That's why the Big Bang theory does not hold water, because it would all be going away from each other. The galaxy is the richest global cluster system known. Halo of galaxy blends smoothly with the intracluster medium. They all must have separated somehow, and now they're all among their own. They must have probably part of a much larger galaxy mass, which is separated into 4 or 5. Then they separated into galaxies of their own. But it all had to come together in each one, and they probably have been doing that the entire time, collapsing and expanding on their own in their own space. So yeah, this one I don't see a volume or masses. 30 billion? Holy cow, the galaxy harbors are supermassive with a mass of nearly 30 billion masses. That's 30 trillion suns. Think about that, 30 billion. So, okay, that's that one. Let's go back to another one here. Supermassive black hole. They put a list of other ones down here somewhere. Where did they go? Where did that picture go? Let's see. How much more convincing do you need to know that the Big Bang never happened? Yeah, those are galaxies. Active galactic nucleus. So what is that? That would be, it seems like learning more about the active galactic nucleus would tell us more about why is a galaxy here if you look at the nucleus of it. How did it form? How did it die? Here's the active galactic nucleus. So, a compact region in the center of the galaxy that has a much higher than normal over some portion. Characteristics: luminosity is not produced by stars. Such excess stellar emission. It creates all these radiation wave bands. AGN, active galactic nucleus. That one says the non-stellar radiation is theorized accretion of matter, center of the host galaxy. Most persistent means discovering distant cosmic time also puts constraints. Their evolution of a function of cosmic time also puts constraints on models of the cosmos. So that might be interesting. So what is their model of the cosmos? They say dealing with the nature, physics, and metaphysics that govern the universe. And those basically just talk about those things. Okay. The nature timeline. Surely this isn't more. No, this is talking about the age. I'm sure the age of the universe, the time elapsed since the Big Bang, two different measurements of the age of the universe. I'm hoping that they're saying the Milky Way. Because early stars, yeah, but it says earliest galaxies. Estimated redshift as being 324 million years after the Big Bang. Yeah, but that isn't. It could be that universes end up collapsing, that they don't live. Galaxies don't live that long. Okay? They end up expanding and collapsing at a rate at which you'll never find one that is that old because of their life cycle. They expand and they collapse much, much faster than what the time frame is from where we are now to what they say was the Big Bang. So, of which is, yeah, that there is 4.5 billion. Yeah, they're saying 13 and they're saying the Big Bang was 15 billion years ago. Surely they don't mean all of them. No, I can't believe that. Surely the earliest. Yeah, no, this is saying the universe, and they're calling the Big Bang, and they're saying that the age of the universe, but not our galaxy, which indicates an age. So, the age is a time elapsed since what they call the Big Bang. It's right in two different measurements of the age of the universe, earliest age, which indicate an age of 13.7 billion years. Somebody called Lambda CDM Concordance model, and a remeasurement based on observation of local modern universe, which is suggesting a younger age. Narrowed down to 20 million. They're saying all. They're saying everything. They're saying the steady state known as the line. Throw a couple big names on here. I don't like this explanation. Describes the evolution of the universe from a very uniform, hot, dense state to the present state, 13.77 billion. Recent high universe, international. Yeah, again, surely this is only talking about the Milky Way. They cannot be talking about all the other galaxies out there. They just can't be. I don't believe it. I won't. The light travel time to the surface, depending on the geometry, is reliable age for the universe. It could be how quick or how soon they live and die. Yeah, it says the age of the universe. Okay, yeah, they threw some good numbers on Age of... There's something called the cosmic calendar. Yeah, I don't believe that either. Maybe on Earth, Big Bang, cosmic, emitted 14. So they're saying the first galaxies formed. The study of galaxy formation and evolution is concerned with the processes that formed a heterogeneous universe from a homogeneous beginning, the forming of the first galaxies, the way galaxies change over time, and the processes that have generated the variety of structures. Nearby galaxies hypothesized from structure formation theories of quantum fluctuations as a result of tiny quantum fluctuations in the aftermath of the Big Bang, or what they call the Big Bang. The simplest model is the observed in the CDM model. It is clustering emerging allows galaxies to accumulate mass, determining both their shape and structure. Hydrodynamics simulation, which simulates, is widely used to study galaxy formation and evolution, but it doesn't talk about the death of a galaxy either. So we'll never see a galaxy die. We always see them like in the midst, in their middle life. Here's a galaxy, but they didn't show it like from the beginning. Here's a galaxy, they didn't show that it's actually collapsing instead of expanding. So it's, unless you can take a look at it like 10 years down the road and see, oh yeah, it's like half a millimeter to the right than what it was. I don't know. So the phenomena, so this is supposed to be a model of the model in which the universe contains three major elements. First, a cosmological constant. Second, dark energy in the standard model of what they call the Big Bang cosmology. So anyway, they're looking at microwave background, large scale structure, abundance of hydrogen, helium, lithium, expansion of the universe observed in the light from distant galaxies and supernovae. So, okay. Accelerated expansion of the universe, a timeline of the schematic, the present, a cosmological time. For some reason, I don't think galaxies live that long, and so that's the longest that a galaxy lives. It grows and it collapses in that amount of time. The dark measure constitutes the lighter elements. Looking for words that explain such things. The great majority of ordinary matter in the universe is unseen. Such invisible stars and gas inside galaxies and clusters account for less than 10% the ordinary matter contribution to the mass energy density of the universe. Nature abhors a vacuum. So the model includes a single originating event, the Big Bang, which was not an explosion, but the abrupt appearance of expanding space-time containing radiation and temperatures that was immediately followed by an exponential expansion of space by a scale multiplier or more, known as cosmic inflation. The early universe remained hot for several 100,000 years, a state that is as a residual cosmic, low energy emanating from all parts of the sky. Yeah, but I don't think that it all came from one single point. I really don't. I think that the galaxies are out there. They have collapsed and been born on their own without coming from a Big Bang of one central original point due to the physics of the universe, of just based on common sense and what I've read and about a galaxy. Okay, that energy is always there. Congratulations, it's the energy that surrounds everything anyway, regardless of that. It's coming from our sun. It's not coming from the universe or the galaxies. Violations of the cosmological principle. The ACDM model has been shown to satisfy the cosmological principle, which states that on a large enough scale, the universe looks the same in all directions and from every location. The universe looks the same whoever and wherever you are. The cosmological principle exists because when the predecessors of the model were first being, there was not sufficient data available to distinguish between more complex models, so we assumed to simply simplify the model. Violations, there were assumed. So homogeneity and isotropy were assumed to simplify the models, and the assumptions were carried over into the ACDM model. However, recent findings have suggested that violations of the cosmological principle, especially of isotropy, exist. These violations have called the ACDM model into question, with some authors suggesting that the cosmological principle is now obsolete. Whoever breaks down in the late universe, this has additional implications for the validity of the cosmological constant in the ACDM model, as dark energy is implied by observation. Only the cosmological principle is true. So this one down here, evidence from galaxy clusters, quasars, and supernovae suggests that isotropy is violated on large scales. Data from the Planck mission show hemispheric bias in the cosmic microwave background in two respects. One with respect to average temperature, the second with respect to large variations in degree of perturbations. The European Space Agency has concluded that the anisotropies in the CMB are in fact statistically significant and can no longer be ignored. Is that saying that the Big Bang did not happen? Are they saying that the background energy cannot be used to quantify the existence of a single point of origination being what they call the Big Bang? That could be the truth. It could be true that no, the Big Bang did not happen because the energy in the background is not following the isotropic rule. The state of the universe around Earth is isotropic at high significance by studies of the cosmic. I think it's just normal energy that's normally there. Universe, redshift, mass collision, velocity, strong tension, due to more rapid structure formation, super voids. Yeah, what about the gigantic voids in between the universes? I guess over several billions of light years, you have plenty of time to move around. There's nothing stopping these universes either. It's all a vacuum, therefore they're moving through a vacuum, through empty space. Dwarf galaxies, thin planar structure simulations predict that they should be distributed randomly on their parent galaxies, about their parent galaxy. Oh, parent galaxy. However, latest read that the seemingly bizarre alignment is just a quirk which will dissolve over time and then be consumed back into the original galaxy. High velocity galaxies. So this one also brings to mind about the Big Bang. If there was a Big Bang, why is this taking place? High velocity galaxies. Why is that taking place if everything was from original point moving away? Are moving away too rapidly to be consistent with the expectations of the ACDM model. This framework is too massive and distant from the local group for it to have been flung out in a three-body interaction involving the Milky Way or Andromeda. So, galaxy morphology. If galaxies grew hierarchically, the massive galaxies requiring many mergers. Major mergers create a classical bulge. On the contrary, 80% of observed galaxies give evidence of no such bulges, and giant pure disk galaxies are commonplace. The tension can be quantified by comparing the observed distribution of galaxy shapes today with predictions from high-resolution hydrodynamical cosmological simulations, the ACDM network framework, revealing a highly significant problem that is unlikely to be solved by improving the resolution of simulations. The high bulgeless fraction is nearly constant for 8 billion years. Fast galaxy bar problem. If galaxies were embedded within massive halos of dark matter, then the bars that often develop in the center regions would be slowed down by dynamical friction from the halo. This is a serious tension with the fact that observed galaxy bars are typically fast. Small scale crisis, high redshift. So yeah, I think I'm getting down the rabbit hole about the original thing here. Yeah, the age of the universe, I don't think they can age it. It's ageless. Even though they're saying that the age of the universe is so old, I think that some of these galaxies cannot be aged that way. They collapse and they expand on their own. There's no way to age them. They've been there. The mass of a galaxy has been there for infinite time. It has just collapsed and expanded on itself on a normal basis. So that's what I think. I'm looking for anything else that I can find that would give information as to what exactly they're saying the Big Bang was, or what a galaxy is when a galaxy is born and it dies. So let's look at that, right? Let's look at galaxy death and see how a galaxy dies. I looked up galaxy birth. Galaxy birth. Galaxy birth does not exist. Oh my God. Because they don't know. There's nobody that wants to even talk about it. They want to talk about, well, this is how a galaxy is born. Wow. Okay. Alright, what about galaxy death? Galaxy death? Galaxy death does not exist either, because the reason why the birth and death doesn't exist is because they don't want to talk about it. They don't want to talk about the death of a galaxy or the birth of a galaxy because they don't know. Okay? And they don't have, like, what about different words? Beginning of a galaxy. Because once you know what the beginning of a galaxy is, then you know what happened. You then look into how they're formed. Forming of a galaxy. Oh gosh. Galaxy begins. Nothing. Oh. Beginning. The galaxy. A galaxy being. Oh, I'm sorry. There's some kind of movie. Galaxy birth. I think I already looked at this and found nothing. What about collapsing galaxy? That would have it. Collapsing galaxy. How do you spell it? I think I spelled it wrong. Collapsing. Oh, there we go. Collapsing galaxy. Oh, it doesn't exist. Anyway, I think I'm done. I think I've proven, I've seen enough information that it proves that the Big Bang didn't happen because of the motion of the galaxies in random directions. I think I have seen that they didn't do that. That galaxies were created from their own mass after collapsing. So, let me look up young galaxy. Of course, young galaxy. Oh, it's a singer or something. Young galaxy. Death Cab for whatever. So anyway, yeah, I can't find anything that talks about what the age of any of them are. The Virgo cluster, you have list of galaxy groups and clusters. This is a collision. Recently emerging. This is the pieces. This is a gravity map, Hubble image, whatever. So anyway, I think that's. I'm gonna have to wrap this up. Okay, I'm kind of done. I think I got off on the rabbit hole near the end of this, but I think that it's due to a lot of I think there's a lot of evidence out there that's unknown, and that they threw in the Big Bang like it's something that happened. And I don't know if there was some kind of political reason or maybe a religious reasoning for coming up with the Big Bang. Like somebody proposed it at one point in time, said, "Oh, there's a thing called the Big Bang, and now it exists." Or like there was this big deal in between all the galaxies, and they're all tied together. I think it sounds stupid. I don't think that that's true at all. I really don't. I think that a lot of this stuff, it's so old that you don't know how old it is. And so the Big Bang kind of gives it a place of being or an existence. In order for it to think about existing, it had to begin with something. So it started with the Big Bang. So anyway, I think the Big Bang is an excuse for somebody to come up with a reason for something. And so therefore, I don't think it's true. I really don't. So anyway, there you have it. I think I'm going to have to bring this to an end. The universe calls on all of it, but then also tries to say it's a definable age, which I don't think it is. The size of the observable, 93 billion light years. Well, that's what you can see. Everything else is beyond that. The light is so diminished that you can't see beyond it. It's an infinite distance. There is no distance. It goes far beyond that. It is an infinite distance. You cannot put a limit to the width of it because it's infinite. About the observable, maybe. Oh, that's about as far away as we can see. But again, there's stuff out here. The whole observable, yeah, it just, sure, it shows this is how far we can see. We're blind beyond that. That's all it's saying. And so, therefore, with that, I'm going to have to call this video to an end because I believe that I have brought up some evidence about galaxies and matter, some details about galaxies and their existence to show that the Big Bang is not true, that it didn't happen. And the missing part is the birth and death of a galaxy. How are galaxies born and how do galaxies die? That's what we need to figure out in order to truly say that the Big Bang is real or false. I still think it's false. I don't think it's true. But first, we have to solve the mystery of how a galaxy is born and how a galaxy dies before we can actually say that, oh, there was something which happened. Because you're saying all the galaxies were together at the time, and I'm saying that they weren't. It's impossible. They're too far apart in order to. Sure, you can see that far. That's fine. That's a distance that over time the mass and star stuff accumulated over this empty space. And if anything existed, it ended up migrating into this universe, and over the eons and infinite of time, the star stuff accumulated. It moved around randomly and ended up accumulating into a universe. Then you had something like a black hole that would collect stuff up, like a vacuum cleaner of space. It would randomly move through space and vacuum stuff up, and then end up being its own galaxy. So I think that's why there's this empty stuff in space. And not that it came from a central point. But anyway, leave your comments below. You can comment. Please subscribe. That's great, to my YouTube channel. Hopefully this raises some big questions about the existence of our galaxy. And please look for some answers to the birth and death of a galaxy, and was the Big Bang real or not. With that, I'm going to end the video.